Alright guys, so we're going to start with number 64. The answer is 27 meters per second if you're getting on here just to check yourself. Otherwise, I'm going to try to, that's my goal, 27 meters per second. So it says the longest record or recorded pass in an NFL game traveled 83 yards in the air from the quarterback to the receiver. Assuming that the pass was thrown at an optimal 45-degree angle, what was the speed at which the ball left the quarterback's hand? Okay, so we're looking for this velocity. We don't know Vx. We don't know Vy. Our initial velocity in the y direction. We don't know how high it went. We do know, though, it's going to take some path like this, so its delta y will be 0 and its delta x will be 83 yards, which was given. Okay, let's go ahead and turn that into meters. Since we know that 1 yard is about 0.9 meters, I'm going to do 0.9 times 83. And we get delta x equals approximately 75 meters. I'm just going to go with that. We also know that AY is negative 9.8 meters per second. So I think this is probably going to give me enough information to find either Vx or Vy. Now we know this is 45 degrees. So right now my process is going to be to try to use the delta y equation to find time and ultimately solve for v. Okay, so since we don't know Vy or Vx, I do know that Vy equals V sine 45 degrees, and I do know that Vx equals V cosine 45 degrees. So I'm probably going to be able to use this information in my equations to isolate V as my variable and just get the answer. I'm going to start by setting up my equations. So I'm going to do delta y, which is 0, equals 1/2 a negative 9.8 t squared plus Viy. So I'm going to go ahead and say V sine of 45 as my Viy times t. Okay, here I have two variables, v and t. So now I'm going to do my delta x. So delta x is 75 meters equals Vx times time. So V cosine 45 times t. So this is good, I think. I have two equations with two unknown variables. So I'm going to solve this like a basic system. So t equals 75 divided by V cosine of 45. Now I can plug this in and solve for V in this equation here. 0 equals 1/2 negative 9.8 t squared. Now we just found over here that t is this. So I'm going to do 75 squared divided by v squared, and then of course we will have to square the cosine of 45. Okay, so there's 1/2 a t squared plus v sine of 45 times t, which is 75 v cosine of 45. Now, from here, we're just going to simplify. We have this v is going to cancel with this v. Sine of 45, or sine of 45 over cosine of 45. You get the tangent of 45. So, and then here we have 75. So we're just going to start typing this in my calculator. Don't know if you can see that very well, but I'm going to try to let you see it. going to say 0.5 times negative 9.8 times 75 squared divided by the cosine of 45 squared. And my calculator's being goofy. Let's see. Too many parentheses? No. Oh, I gotcha. Sorry, guys. Okay. Holy moly, this is a big number. So we have 0 equals negative 55,125 plus, now sine over cosine is tangent, tangent of 45 is 1, so this is 75 here. And we can't forget right here I need my v squared in the denominator. So now we're just going to take this to the other side, so we get 55,125 over v squared equals 75. Multiply both sides by v squared, and then of course divide by 75. You should get v equals something. Let's see. 55,125 divided by 75 gives me 735, and then the square root of 735 is 27.1. Yay, we got it. Okay, so in this method, we basically used the fact that these are basic trig functions for Vy and Vx to actually, instead of needing to solve for Vy or needing to solve for Vx, we just went ahead and solved for V. I'm sure there's another way to do that,